Okay, let's see if you really know what the Pythagorean theorem is. So, I want you to simply write it down or just say it out loud. You probably got a squared plus b squared equals c squared. Now, is that the Pythagorean theorem? Is that it? Well, if this is true, then if I make a equal 1, b equal 2, then c would be 6, then you would get 1 plus 4. That doesn't equal 36. It didn't work. Why didn't it work? Okay. You're saying, oh, it applies to triangles, right? Triangles. Okay, we'll talk about triangles then. So, triangles, right. So what if I put for this triangle, ABC, where it's a right angle, then a squared plus b squared equals c squared. So is that the Pythagorean theorem? Well, actually it's not. Look. Here's a triangle. And this is a 90-degree triangle, so we'll just do 45, 45, so sides will do the same, and then you have radical 2. Okay, that works. But what if you had a triangle in a sphere like this, and you had A, B, and C? These angles, could not be the same. What if they're not the same? Right? So let's just break it down a little bit. So let's draw a square. So I drew a square and a square within a square. So rather than just knowing, oh, I know that a squared plus b squared equals c squared, I want you guys to understand and realize why that is true. So this is how I'm going to prove it to you. So we all know that a square has right angles on all its sides, right? So let me just label, and look, I drew triangles all around here when you put the square inside the square, right? That's what it forms. So let's just label the sides. So I labeled all the sides, and notice that all these hypotenuses, or hypoteni, I guess, are the same length. So just looking at this, let's break it down a little bit. Here's just the outside of the first square. Remember, we have the A, B, and the A, B when we drew the triangles inside like that. So this is just the outer edge. So look at here. If you have these, those two portions make up the side, right? So A plus B is one side. What about over here? B plus A plus B, same thing. So over here is also A plus B. So what would be the area? The area would be, or pretty much, A plus B squared, right? Understood? Okay, now let's look at the second part, this inside square. So we have the outer sides are all C, right? So that means the inside is C squared, correct? Okay, so if we have the square and the four triangles that make up the original structure we had, which was the square inside the square, then you'll get a squared plus 2ab plus b squared, which comes from this here, equals c squared. Now, we're not done yet, because what's the area of a triangle, right? So you have a triangle, the area is 1/2 base times height, right? So, and since there are four triangles, you would add the four triangles, 1/2, and we'll do base, or height, base, whatever. There we go. Okay, so then you get c squared plus 2ab, and then if you notice, these two cancel, and you're left with a squared plus b squared equals c squared, and that is why it is true. There's your answer. Boom. And now you can understand why the Pythagorean theorem is as shown. One more thing I want to add. So I want you guys to, rather than memorize the Pythagorean theorem or any formula, understand where it comes from. Because if you understand where it comes from, you can better apply it to when you're using the formula or the concept, and you'll have a better knowledge of the topic in general. So I encourage you to understand rather than memorize. And it's a tough transition, but if you put in the effort, it's really going to pay off in the end. So good luck.